This screencast is going over how to factor using the GCF. GCF stands for greatest common factor. The idea here is that we are reversing our distributing process. We're going backwards. We had, if we were distributing some letter A or some number A multiplied times the quantity B plus C. We take A times B to get AB. We take A times C to get AC. For example, if I have 3 times the quantity x plus 2, we took 3 times x, which is the 3x, and 3 times the 2, which is 6. Normally, we don't write out 3 times x times 3 times 2. We just go to 3x plus 6. When we're factoring using the GCF, there's 2 things we're looking for to find that GCF. First, we're looking for a number other than 1 that divides without remainder into all coefficients. The coefficients, remember, are the numeric parts of the term. And secondly, we're looking if a specific variable is listed in all terms. If it is, then you can factor it out and you want the lowest power of that variable. If it's not listed in all terms, you cannot factor it out. So let's get to some examples. Let's say, for example, I am given 5x plus 15. So we start by looking at the 5 and the 15 and ask ourselves what number goes into 5 and 15 evenly, and we want the largest possible number. In this case, that number is 5. We also then check for the x's in every term, and in this case, I only have x in the first term, so I cannot factor out the x. So we try and figure out what did we multiply 5 by to end up with 5x plus 15. Sometimes it's helpful, especially with the numbers, to divide. 5 divided by 5 is 1. Sometimes we do need to write the 1. This is not a particular case where we do, because we also have x that is multiplied times that 5, and we will have an x there. Then we move on to the 15. 15 divided by 5 is 3. It's a positive 3. We believe that this is going to be our answer, and from here we are going to see if it checks out by multiplying back. 5 times x is 5x. 5 times 3 is 15. 5x plus 15 is what I originally started with, so we're good. Let's try another example. This time I have 2x squared plus 14x. So again, we begin with the numbers. What is the highest number that goes into 2 and 14? That would be 2. Do I have x in every term? This time I do. So I am now looking for the lowest power of x that I have, and that is x to the first. Now we're again asking ourselves, what did we multiply 2x by to get to 2x squared? 2 divided by 2 is 1. X times x gets me x squared. Again, I don't need the 1 there in front of my x. 14 divided by 2 is a positive 7. And we already multiplied by x, and we don't need an additional x because we only have x to the first. So again, I think that's my answer. We're going to double check. 2x times x is 2x squared. 2x times 7 is plus 14x. That's what I started with. We're good. Moving on, let's try 6x cubed y plus 18x squared y squared minus 21x squared y. Getting a little bit more complicated because we have multiple letters as well as our coefficients to worry about. So I'm looking at the 6, the 18, and the 21, and the highest number that goes into all 3 of those is 3. I can't use 6 because 6 doesn't go evenly into 21. Do we have x in every term? Yes, we do. The lowest power of x we can factor out is x squared. Do we have y in every term? Yes, we do. Lowest power of y is y to the first. Okay, let's see what we multiplied 3x squared y to end up with those 3 terms. 6 divided by 3 is 2. I have x squared. X squared times x to the first gets me to x to the third. I have y, and I only have y to the first in that term, so just 2x is all I need. 18 divided by 3 is 6, so we need a positive 6. X squared times 1 is x squared, so in other words, I don't need to write down an x term. Y times y gives me y squared, so we do need the y term. Negative 21 divided by 3 is negative 7. X squared times 1 gives me x squared, so I don't need to write down the x. y times 1 also gives me y, so again, I don't need the y term. So I believe 2x plus 6y minus 7 is what I need inside parentheses. Multiplying to check. 3 times 2 is 6. X squared times x to the first is x cubed. Y comes along. 3 times 6 is 18. X squared comes along. Y times y is y squared. 3 times minus 7 is minus 21. X squared y both come along, and as I check, everything looks good. We did it very nicely. Last example, we have 18 x to the third y minus 12x squared y plus 6x squared. Once again, we are looking at 18, 12, and 6. We want the highest possible number that goes into all of those terms. That would be 6. I could take 3, but it's not the highest possible, and again, we're looking for the greatest common factor. I have x in all three terms. The lowest power of x is x squared. I do not have y in all three terms. It's missing from that third term, so we cannot factor out a y. 18 divided by 6 is 3. I have x squared. If we multiply by x, that will get me to x cubed. Y needs to be there, so we have the y. Negative 12 divided by 6 is negative 2. X squared times 1 gives me x squared, so I don't need the x at all. I do need a y. 6 divided by 6 is 1. X squared times 1 is x squared. Now, I can't leave it blank because I had three terms, so we actually need to put a 1 there. Here is the case where you need a 1. Okay, let's check to make sure that we multiplied right, or factored right. 16 times 3 is 18. X squared times x is x cubed. Y. Minus 2 times 6 is minus 12. X squared. Y. And 1 times 6x squared is plus a 6x squared. And again, we check and everything is good. Thank you.